Believe it or not, even if Dwyer High School is like right here, around the corner, he's the first student from Dwyer that was ever picked to take part of this internship. So congratulations for this great achievement. And also he amazed me when I did the interview with him. He's really into robotics and he told me everything about it. And he's also one of the founding members of the Squidworks Robotics. So good luck.
Thank you. Thank you, Ilaria. Good morning. I'm Lance Brown, and this summer I had the opportunity to work in partnership with the Mechanical Workshop and the Fitzpatrick Lab. My project this summer was to create a rotation module for a multi-photon telescope system. My project specifically was to create a rotation module for a 2-photon microscope being developed in the Fitzpatrick Lab. 2-photon microscopes are widely used in neuroscience because they are able to see deep into the brain. The Fitzpatrick Lab uses them to study the visual cortex specifically. As you can see, it's in the back of the brain and it is hard to see from a conventional perspective. The 2-photon microscope also includes 2 different lasers. The first laser stimulates the neurons. The second laser records the stimulated neurons. However, they do face technical challenges when using the 2-photon microscope in non-conventional uses. They are available, but not easily customizable. So for our purposes of using it from an off-angle perspective of the brain, it is harder to use. Calibration can also be time-consuming, as every time you move the 2-photon microscope, it needs to be recalibrated, including the laser strength and the angle. So my goal for this project was to allow the researchers to have different angles of rotation around the x-axis while giving them the ability to record more data at a faster pace. The module for this project should be able to have negative 30 degrees to positive 30 degrees of rotation. This means it should be able to see from the side and from the top as well. It should also be able to hold the weight of the front of the microscope, around 40 pounds. And in addition, it should be able to last the lifetime of the microscope. But before I can make the part, I have to understand the location of the 2 lasers in this microscope. Laser number 1, which activates the neurons, is located in the base of the microscope and is in a fixed position. For it to reach the sample here, it has to go through the mirror, this first mirror found here. Laser number 2, located on the top of the microscope, is also in a fixed position and bounces off the same mirror that laser 1 goes through, and then they become one singular laser. This laser then is used to record the measurements and information needed for the scientists. What this means is the module has to be in between the placement of the 2 mirrors, the one before it reflects the laser and the one before it goes above the sample. It also means that my part has to be short enough not to interfere with the other parts of the microscope, since this is not the only features of it. It cannot interfere with the lens in the back, and it cannot interfere with the computer in the front that records all action done by the lasers. The middle of the module has to be able to have a large enough diameter not to interfere with the laser path of the laser. If interfered, the laser becomes unusable and is not able to record any information. It also has to hold the weight of any attachments that go on the microscope. Attachments can go on the top and on the bottom, so it has to be durable. Knowing this information, I was able to design my part in SolidWorks. Here's an exploded perspective of my part. As you can see, it has 3 parts specific for rotation. This part in the back is the part that attaches to the base of the microscope. When attached to the base of the microscope, it's able to keep this brass pipe mounted, and this brass pipe is what is rotated around. This front part is what goes around this brass pipe. Together, they're able to rotate the front of the microscope. This handle is included to make it easier for the scientists to use, and the brake is there to lock it into a singular position for consistent angle measurements. Here is a video of the angle of rotation provided by the part. As you can see, it is locked into 30 degrees to negative 30 degrees, respectively. Because of the restriction of angle guide in the back, it will not overextend its reach and therefore reduce its chance of failing. It also has it can stop at any point during this rotation, not restricting in anywhere in any of that 60-degree range. For designing this part, I use SolidWorks. For machining this part, for the aluminum part in the middle, as you see here in this mock-up, I used a lathe. However, for the rest of this mock-up, it's 3D printed parts and acrylic. I have the mock-up with me right now. As you can see, the sample would go right here. Once unlocked, you're able to rotate it, lock it, and keep in this position. Once in this position, it cannot rotate anymore. It has to be then unlocked and rotated to whatever angle you prefer. This way, they're able to keep it in a singular position while keeping its structural integrity. Because this part has small amount of mounting screws, it should be able to fit in similar sized microscopes and give the extra degree of rotation. It is also small and it's pretty discrete, so as long as it can go inside the base of the microscope, it can still provide the rotation that scientists may want for their microscopes. It can also sustain a sufficient amount of weight, so it is versatile for other types of projects. In addition, it should last the lifetime of the microscope. So for longevity of the issue, it should not be a problem. I would like to thank my mentor, Marcus, Dion for helping me make this markup, Ben Scholl for giving me this amazing project, Ilaria and all the other interns for making this internship just a blast, and the members of Brain Trust for making all of this possible.
Does anyone have any question for Lance? We prepare a lot for the questions, so yes.
Are there little marks so they can see how far they've twisted it, so they can get back to the same place?
The question was, are there any marks on the angle guide so they can see what they're doing? Not in this version. However, for future iterations, it is planned to have a measurement for them to be able to consistently hit the same angle. Thank you. The question was I able to patent that? No, sadly no. This concept was given to me by my mentor on a similar types of microscope. I designed it specifically to fit this one and modified it so it works for this one in particular.
Any other question? Good job.
Oh, yeah.
Oh, there is another one. Wait, no, you can go ahead.
The question was, where do I plan on going to college? I'm looking at several colleges. University of Florida, Georgia Tech, Vanderbilt are my top choices at the moment. Thank you.
You did awesome.